There is no such force as gravity. I mean, we have all heard the story about an apple falling down and Isaac Newton discovering gravity, but Albert Einstein says it's not the apple which is falling down, but it's the ground which is accelerating upward towards the apple, and the apple is simply floating in space without any force acting on it. But wait, how is that possible? We feel gravity all the time. I mean, we feel a weight because of it, right? Well, for that, Einstein says, imagine yourself in a closed rocket with no windows, no way to look outside. And that rocket is accelerating upward at exactly 9.8 meters second square. Inside it, you would feel exactly the same as you do while standing on Earth. If you will measure yourself, you will weigh the same. If you will drop something, things will seem to fall down as usual. And there is absolutely no experiment you can do inside that to tell whether you are being accelerated in space or standing still on Earth. Then why don't you believe that Earth as well is accelerating upward? Okay, but this sounds wild. If the Earth is accelerating upward, then why not it is expanding from all direction? Why is it always the same size? Well, that's because of curvature in space-time. Relax, let's understand how. So let's plot a favorite space-time graph where time is treated as a physical dimension. Any object at rest which is not moving in space will always follow the straightest possible path. In this case, all its motion is through time because it's not moving in space, but of course time will run as usual. But if it starts moving through space, its motion gets shared between space and time. So now its coordinate time will run slower. And this is a proven fact, and I have explained it in great details in episode 20. But for now, just keep two things in mind. The length of both lines remains the same because from their own perspective, time is always running normally. And second, if any of these lines start curving, that simply means the object is accelerating. Common sense, right? And I know it's getting a little boring, but now when we fold this graph into a cylinder, the length of the cylinder represents motion through space and the circumference represents time. So it's like a clock. One full round means 1 unit of time. So the object at rest completes 1 full unit of time, as you can see. But the moving object has not completed the full round yet, which means time is running slower for it. Easy, right? Now, what does this represent? Two objects at rest, right? But now let's bring in some heavy masses like Earth, which will stretch this space-time. Imagine this is the ground and this is the apple attached to the tree. And remember, it's not falling right now, it is attached to the tree. So we will fold this again. And since it's a proven fact that the time slows down as you get closer to a massive object like Earth, which I've also explained in episode 19, by the way, the ground line should not complete a full circle like the apple line because time runs slower near the Earth, but their length still have to remain the same. Remember? So how do we fix this? We stretch this region into a bigger cylinder so the length stays the same, but it no longer completes a full circle. And since time slows down smoothly, the shape now becomes something like this. And it's time for the climax. When we open this, look what we get.